Imagine getting an email from a corporate procurement team. They love your service, but they've decided to reject your $200 quote for a custom part. They ran the job internally using raw materials, and they claim the part only cost them $20. From the perspective of the finance department, this looks like a massive 90% savings win and a successfully optimized supply chain. They've fallen into the trap of material-only math. They calculate the weight of the raw nylon or metal powder, multiply it by the material cost, and stop there. But that $20 figure is an illusion. It ignores a heavy operational overhead that rarely shows up on a raw material invoice. To understand why internal production often bleeds cash rather than saving it, we need to audit the missing $180, line item by line item. Producing a commercial-grade functional component requires an extensive industrial ecosystem. These parts cannot simply be manufactured in a vacuum. First is facilities infrastructure. You need pneumatics for consistent line pressure and dedicated HVAC units to filter fine polymer particulates and maintain strict temperatures. Running these specialized facilities 24/7 causes commercial utility bills to spike, adding massive expense to every minute of production. Even when the machine finishes its run, the process is only half complete. A raw component is rarely ready for use immediately. The true cost must include the downstream workspace, powder removal stations, bead blasting equipment, and the precision machining lines needed to hit tight tolerances. There are also mandatory ongoing costs for the disposal of hazardous waste, including contaminated filters and chemical runoff. These invisible systems act as a compounding tax, inflating the baseline cost of every part long before it reaches the assembly line. Then there is the human element. Parts do not finish, inspect, or manage themselves. You compensate specialized personnel, engineers to optimize digital designs and prevent warping, and technicians to handle messy post-processing and rigorous quality inspections. This brings us to the scrap rate, the ultimate budget killer. Production floors face constant operational friction. A power surge can ruin a 15-part batch. Thousands of dollars in time and material are lost instantly, adding a massive surcharge to the remaining parts. Finally, you have to account for inventory and shrinkage. Raw materials require climate-controlled storage and are highly susceptible to expiration, handling damage, and internal tracking errors. When internal employees spend hours managing a run and a single error destroys a batch, the original $20 estimate is completely obliterated. Does this mean localized production is always a mistake? This depends entirely on volume. In-house cost per part starts extremely high due to massive facility and labor overhead. By running 24/7, you amortize that overhead across thousands of parts, dropping internal costs below the outsourced baseline. Local production also makes sense for rapid day-to-day prototyping or for aerospace and defense projects where high-security IP must stay within your own walls. But for low-volume, custom projects, we have to look back at that $200 quote. That $200 represents the total transfer of operational risk. The service provider absorbs the costs of facility upkeep, specialized labor, and failed runs, delivering a part that is already certified and flawless. Supply chain optimization rests on capacity and risk management. For many companies, the premium paid for an outsourced part is the price of guaranteed quality and zero operational liability.